Good day, guys. Today we'll be programming the sorting station in ladder logic, right? So now the purpose of the sorting station is to separate different workpieces. So from here you can see that you have a red workpiece, black one, and a silver or metal one, right? So now the sorting workstation, you can program it such that, like, let's say if a silver part comes through, it could be diverted to the first slide, and let's say if a red part comes through, diverted to the second slide, and then other parts they want to be diverted to the third slide, right? So now let's get started. We'll be using this guide, right? It has instructions. I've put in instructions so it's gonna be easy to follow, right? So now we'll be following these instructions, right? So now they are saying when the part placement sensor and the start push button activated, the conveyor belt begins to move, right? So now our part placement sensor, according to our inputs, our part placement sensor is I0, right? And our start push button is P0, right? And then so we have to do that here in CODESYS, right? So we come to the line, right? And then we put in our P0, right? So it's P0. So our conveyor belt, according to our inputs, again, it's Q0, right? So say Q0 here, right? And then we'll create a loop, right? So we're able to send continuous signals, right? So say Q0 here, and then now we have to fulfill the end condition. Like, not only the start push button activates the conveyor belt, it's also the part placement sensor, right? So now, like, since it's an end condition, as you can see from the statement here, it's an end condition, the part placement sensor and the start push button have to be activated, right? So now if you put this here like this, right, as I0, you did not fulfill the condition because they are not under, like, for you to fulfill the condition, both the I0 and the P0 have to be under the ledge, because now the input of I0 will not be ledged, so you won't be able to fulfill the condition. So to fulfill the condition, you have to put I0 here under the ledge, right? You have to put it here, I0, right? And then here, if you still remember, we always have to put in a stop button so we're able to stop our process. So here you'll put your P1, right? Your stop button, right? And then now you'll run your code, and then you'll see what happens, right? So now going back to our CIROS, right? If we put in a workpiece here and then we press the start push button, you can see our part begins to move, right? But then, as you can see, there's a plunger here that's preventing our part from moving fast. So we have to make sure that it retracts, right? So now we go back to our instructions and see, like, what are the instructions to make it retract, right? So now let's just highlight this before we move on, and then we'll come back to this. Let's deal with the plunger now. So now they're saying when the plunger sensor is activated, the plunger will retract 2 seconds, allowing the workpiece to move through, right? So now, since they told us that the plunger will retract after 2 seconds after the part has arrived, like, that should alert us to the presence of the timer. So now we should delay the plunger. We should delay the plunger sensor by 2 seconds. We should delay the activation of the plunger sensor by 2 seconds, therefore delaying the plunger from retracting for 2 seconds, right? So now we come back here, right, and then put in a line, right? So now, since we are dealing with our timer, right, we go to our function blocks, right, and then we drag the RS component. So now I'm going to remind you again, the RS component is used to latch our timer, right? So if they told you just the time, you have to make sure that you latch it always using the RS component, unless they told us it's an unlatching timer, right? But since we're dealing with a time, like they just told us the time, we have to assume that the timer is latching, right? So that's why we use the RS component, right? So now we also now get the timer, right? And then we plug it in here, right? And then make sure you also declare these variables, right? So now we are delaying the plunger sensor by 4 seconds. So now if you look here in our input, the plunger sensor is I4, right? So you can say I4, right? And then also put in your P1 here to reset, so you're able to stop the process. But then again, you have to negate it because the P1 it's normally closed. If you don't negate it, it's gonna continuously reset our time. So always have to negate it, right? And then now, since we're delaying the plunger, right? Since you're gonna be using this timer once, you don't have to also create a memory, right? You can just make the plunger the direct output, which means you can make Q3 the output, right? You can put it in as Q3 here, right? And then now, they said for a period of 2 seconds, right? Set it for a period of 2 seconds, right? So now we're gonna make this 2 seconds here. So it's gonna be T hashtag 2 seconds. Yeah, I think it's 2 seconds. Is it 2 seconds? Yep, it's definitely 2 seconds, right? So now this is our timer, right? So now we run our code, right? And then we log in with, oh sorry, before you log in, right, I made a mistake. So now, since you are dealing with a timer, right, every time you add a timer, you build. So now you build and you select the variable and then you build again, right? Don't forget building. It's very important because if you don't build, CIROS will not recognize your timer, right? So now you log in and log in with download, right? So now then you go back to your CIROS, right? And then we attempt to run our code. So now let's just take out this workpiece here, right? So we can start afresh, right? So now we put in another workpiece, right? And then all right, so now you make sure you play, right? And then now as you can see, after 2 seconds our plunger is retracting, right? So now we go ahead and continue, right? So now they're telling us when the workpiece reaches the slide sensor, right, the plunger will revert back to its original position, right? So now, if you can look at the current state of our plunger, it's currently gone, right? The circuit is open now, as you can see, right? So now they're telling us, like, going back to here, they're telling us when the workpiece reaches the slide sensor, right? So the slide sensor here, it's this sensor here, right? I2, right? So I2 becomes activated when the any of the workpieces they slide between like these 3 slides. So like if a part slides through the first slide, it's gonna get activated even for the second one as well as the third, right? So you can conclude that the purpose of the slide sensor is to detect the presence of parts that are sliding down the slides, right? So now they are telling us that every time, it doesn't matter the kind of workpiece, whether it's metal, the red one or the black one, as long as it goes down the slides, right, this sensor is going to be activated, right? So, and then they're telling us to use this sensor, right, to make the plunger revert back to its original position, right? So now how we do that, right, is that now we look for that sensor, right, the slide sensor, which is we can even check here, it's I2, right? So we're going to also use it to reset our Q3, make our plunger go back to the original position, right? So then how we do that is that we insert a parallel here. Since we are trying to reset Q3, right, we're gonna put our I2 here, right? So now after we put our I2 here, right, we have to evaluate the state of the sensor, right? So now we go back to our CIROS, right? So now, as you can see, our ISO sensor is normally open. As you can see, it's currently off. It only becomes on when it detects a workpiece sliding down, right? So now you can conclude that we don't have to negate it because it's only going to get activated when the part slides down one of the slides, and then that's when it's going to get activated, and then it's going to reset our timer, right? So yeah, that's the situation. So now, if we let's run this. So now we run this, right? And then you go back to your CIROS, right? And then we put in a workpiece, right? Say our plunger goes back, and then you'll see when I2 get activated, the plunger reverts back to its original position, right? So now I can go back to the document, right? And then now we've fulfilled this condition, right? So now we move to our diverter one. So, all right, so it may be labeled as a diverter. I think in the diagram I might have labeled it as a stopper one, right? So it's the same thing. Diverter one is the same as stopper one, and diverter two is stopper two. Doesn't change anything, right? So now with diverter one, we'll be sorting out the metal part, right? So now they are saying here, when the metal or color sensor and the metal sensor are both activated, diverter one will move, right? Or it will be activated, right? So now how we do that, as you can see, like, be aware of the end condition, right? So now again we go back to our CODESYS, right? And then now we put in our input. So like we're looking for our color or metal sensor. So our color or metal sensor, it's I5, right? So we say if I5, right? And then we want to activate diverter one or stopper one, right? Which is our Q1, right? So we say Q1, right? And then we loop with Q1, right? We loop with Q1, right? But then to fulfill the end condition, since they said both the color of metal sensor and the metal sensor activated, right? That's when the diverter one will be activated. So now we have to also put in our metal sensor, which is I6, right? So we put in I6 here, right? So now then we put in our stop button, right? All right, so now, ladies and gentlemen, this is the condition that will fulfill, this is the condition that will make sure that if a metal part is coming through, right? So when the metal part is coming through, I5 and I6 will be activated, right? And then that is when and only when the diverter one will be activated, this diverter here, right? So that is the only time when would be activated, right? So now to trial this, we have to use a metal part, right? Since we are sorting out the metal part, right? So okay, I forgot to reset. So now, like, try and make sure you reset everything, and then we'll remove this. Since we are trying to sort the metal parts, we have to see that it goes to the right place, right? So now here, right, we run our code, right? Okay. So now going back to CIROS, okay, perhaps all right. So let's take this out and put it in again. All right, perfect. So now, as you've seen, like that's the only time. So now, like that's the only time where, like where Q1 got activated, right? So now we have to make sure that Q1, right? So let's say a metal, the what you call a red or black part is coming through next time, right? We have to make sure that this thing goes back to the original position, so it doesn't push the other parts like onto the first line. So you have to make sure that it goes back. So now going back to instructions, let's see how it goes back. So now they're also saying when the workpiece reaches slide 1 sensor, the diverter will revert back to the original position, right? So the slide sensor again, slide sensor is right, yeah. Our slide sensor is I2, right? So now we're using I2 to make our diverter go back, right? So now to make it go back, right, we put in our I2 here, right? So let's put in our I2, right? Then again, we have to evaluate the state of I2. So I2 again, as I said before, it's a normally open, right? So now, since it's normally open, if we come here and put it in like this, right? Since it only becomes on when it detects the workpiece, current don't flow into Q1, right? So therefore, you have to convert it into a normally closed by negating it, right? So that is when now our circuit will work, right? So now what's going to happen now is that like our part is going to come through, then diversion is going to be activated, and then when the part slides down and then this sensor becomes activated, our diverter will go back, right? So we can also run that, right? You log in with download, and then you press play. So now going back here, we put in the workpiece again, and then now as you can see, it went back to its original position, right? So now we are done with that, and then now let's sort out the other parts for diverter 2. So now they are saying when the color or metal sensor is activated, diverter 2 will be activated 1 second, after 1 second through a non-latching timer, right? So now non-latching timer, right? The non-latching part, that's a keyword, right? So now they are saying when the color sensor, right, it's only activated, that is when diverter 2 will be activated to sort out the red part, right? So now again, coming back here, right? So now we have to, so like since they said a non-latching timer, right, we have to look for a color or metal sensor, right? So our color or metal sensor is I5, right? So our I5, then since it's a non-latching timer, we won't be using our RS component because RS component is going to latch our timer, right? We're just going to take the timer as it is. So our timer as it is not latched. And then we drag it and then put it in here, right? Right. So this is our timer, right? And make sure it's declared, right? And then they said after 1 second, so we're going to say T hashtag 1 second, right? And then while we're trying to activate our second diverter, but we can't activate it directly from here, so we have to create a memory latch, right? So we come here and then we say M0, right? M0, right? But then there's a conflict with this, right? The conflict that's created like from this code, right? It's since we are saying like for the second diverter will be activated by also I5, right? So now let's say if a metal part is coming through, right? The metal part triggers both. The metal part triggers both I5 and I6, right? So so even if like we're trying to actuate the first diverter, right? Yeah, we're trying to actuate the first diverter, right? Even this code will be triggered, right? And therefore the second diverter will also be activated. Let me just show you by finishing up the diverter. So now we'll take this memory, right? And then we say M0. And then since we want to activate our diverter, which our diverter 2, which is our Q2, right? We loop using Q2. right? And then we put in the stop button, right? So I'm just trying to indicate to you the conflict with this code, since even when a metal part is coming through, it's gonna trigger this code, right? So now if we build, since we added a timer, and then we run this, and then you press play, you will observe like both of the diverters being activated, right? Because of the conflict in that code, right? So I wanna, the metal part would be a perfect candidate for this, right? So I want you to see both screens on what's gonna happen to I5, right? So now metal part is on, right? And then now we press play. So now you can see like both of the diverters are getting activated, and that is not supposed to happen, right? We only want, like, for one part, we only want one, for a certain part, we only want one diverter to be activated, right? So now, to make sure that this doesn't happen, since like even if it's a metal part coming through which activates both I5 and I6, this is going to be activated. So now we have to say here, right? We have to insert another contact here, right? So now we have to say put I6 here, right? And then we have to negate it, right? Here, like this. We have to negate it. So now this new condition is saying if I5, only I5 is activated and not I6, right? So like, as you can see, like it's a direct opposite of this of the above there. So it's saying only when I5 is activated and not I6, right? So now, like, since it will evaluate our code by verifying that I5 is, for the second part, it will look at I5 and then it will determine I5 is correct, right? Then okay, cool, right? And then it's gonna look for if I6 is on or not, right? So if I6 is on, it will signal to it that only diversion should be activated, right? But now if I6 is not on, right, it's sort of like it's telling it like that Q2 is the one that's supposed to be diverted, right? So now we run this and then you'll see the difference right now. Now you put in again our metal part, and then now as you can see how the condition has been fulfilled. Only one of the diverter is getting activated to actuate the, or to direct the part to the first light, right? So now let's see for the red part, right? So now as you can see for the red part, the second diverter is getting activated, right? But now we have to make sure that this diverter also goes back to its original position, right? And then how we do that is that now we go back to instructions. So now they are saying when the when diverter will return back to its original position after the workpiece reaches the slide sensor, right? So now again similar. So now after the part, they're saying after the part slides and then activating this sensor, that's when our diverter will go back, right? So now then again we just come here, right, and we stop it here where we activated it. So now we put in our I2 here, right, as I2, and then we evaluate the state of the sensor, right? So now if our sensor since our sensor is normally open again, as I've been saying throughout the video, right, current don't go to Q2, so that's why we have to negate it to convert it into a normally closed, right? So current can go through, right? And then now that's how we fulfill that condition. But now before we run this, right, so now we are done with this, right, I want us to come back to this condition. So now they are saying, like, when the workpiece reaches the slide sensor, the conveyor belt will stop immediately, right? So now the slide sensor, right, again. So now the slide sensor is also stopping our conveyor belt 1, right? So now we just simply come here to the line where we activated the conveyor belt here, right? We activated our Q0, right? And we stop it here, right? So we say I2, put I2 here, and then again, since it's normally open, current don't go through to Q0, right? Therefore, we negate it, right? and then now we can run our code. And then if we go back to here, right, so now if we put in the, let's start with the red part, right? So now if a red part is coming through, you can see the delay, and then the diverser getting activated, and then it going to the second slide, right? And then now let's say a metal part is coming through, right? Oh, right, sorry, I forgot to put in a metal part. Okay, so now let's say a metal part is coming through, right? So now you can see first diverser is getting activated and then sorting it out to the first slide, right? And then now you can see the, what you call the black part, right? So the black part doesn't trigger any sensor, right? So if it doesn't trigger any sensors, won't like tell you to activate any diverser. So therefore it will fall onto the test slides. Let me demonstrate to you right now. So now let's just put it in. So it goes to the test slide, right? So yeah, ladies and gentlemen, this is how you program the sorting station, right, to sort out different workpieces, right? So yeah, thank you for watching, right? And then in the next video, we'll be programming the sorting station using structured text, right? So thank you very much, ladies and gentlemen, for your time.